We gave it eyes to solve the secrets of the universe. But we permanently closed those eyes, its cameras, decades ago because it no longer had the power. This is deeply ironic, because Voyager 2's greatest discovery wasn't the stars, but how fragile knowledge truly is. It is now a blind messenger, 13 billion miles away. The original software that ran it has been erased from the Earth. The engineers who knew that language are no longer alive. That is why, when it approaches a star in 40,000 years, it will not be able to send us a single photograph. But do you know what is truly chilling? The universe doesn't just erase the future. It also erases the past. If you too fear this cosmic erosion of knowledge, subscribe, because you will see that the greatest secret of the universe is silence. We are beginning. For years, we thought space missions were about sending a command. You write an order, the signal travels, the machine obeys. But we were wrong, because the story of Voyager 2 isn't about sending commands, it's about listening to a progressively weakening whisper. And when that whisper falls silent, the real fear begins. Because the greatest horror in space isn't monsters or black holes. The real horror is knowledge itself, slowly, piece by piece, disappearing. We now understand that our greatest enemy is not distance, but forgetting. The first act of this forgetting is the depletion of energy. Voyager 2 doesn't draw power from the Sun. Where it is now, the Sun is just a slightly brighter star among others. That's why its power comes from the heat generated by the slow decay of the plutonium it carries. This is an atomic battery. Initially, this system provided the mission with about 470 watts of power. This is about as much energy as a few light bulbs in a home. But this power source has a cruel rule. It never increases, it only decreases. Every single year, including the degradation of the thermocouples, the craft permanently loses about 4 watts of power. 4 watts may sound like a little, but it is an irreversible loss. This is why, for decades, the mission has become an art not of addition, but of subtraction. The engineers are in a relentless negotiation with this shrinking energy budget. This negotiation is a conscious amputation, performed to keep the craft alive. Because turning off a heater, sacrificing a sensor, or silencing an instrument is the price paid to hear the craft's voice for just a little longer. This slow and methodical death teaches the first and most fundamental fear of space. Time consumes all things. But this slow death is only the simplest part of the story. What is truly terrifying is that what we lose never comes back. This is the second and deeper act of forgetting. The permanent erasure of memory. The most striking example is Voyager 2's eyes, its cameras. Those cameras sent us the iconic first portraits of the outer planets. But, decades before the planetary mission ended, they were shut down to save power and memory. This wasn't a simple shutdown, though. The software that operated the cameras was completely deleted from the spacecraft's brain. Worse still, the specialized computers on Earth had understood that software no longer exists. The engineers who spoke that language fluently have either retired or passed away. So, even if someone said, "Let's take one last photo tomorrow," there would be no way to do it. The language to give the command, the software to understand the command, and the people to speak the language are all gone. This is the story of how knowledge itself dies, beyond the hardware. This long goodbye does not consist of a single, clean moment of closure. It consists of small, irreversible surrenders. Each one closes a door that can never be opened again, and it shows us the second terrible truth of space. The universe does not just make the future uncertain, it actively erases the past. And what if everything goes right? What if the power slowly fades? Memories are erased, but that whisper still comes. This is where the third, and perhaps most unnerving fear, comes into play. The incredible fragility of the connection. Our entire relationship with Voyager 2 depends on an antenna locked precisely onto Earth. The slightest deviation of that antenna from its target means that faint signal is lost in the infinite void. This aiming task is performed by 16 small thrusters fed by a single tank of hydrazine fuel. For decades, the craft has been using puffs of this fuel to keep itself aligned. But that fuel is not infinite. At launch, it carried about 100 kilograms of hydrazine, calculated to last until the 2030s. Just like the plutonium, this fuel only decreases. When it's gone, the thrusters fall silent and the antenna slowly drifts off target. The craft might be alive, it might have something to say, but it would be looking in the wrong direction. But there is an even more delicate vulnerability. This fuel must not freeze. A crack in a fuel line would destroy all steering capability in seconds. That's why the signal Voyager sends us is an incredible engineering triumph. That signal leaves the spacecraft from a transmitter with less power than a refrigerator light bulb. On its journey of over 13 billion miles, it becomes so weak that the massive 70-meter dish antenna in Australia can barely hear it. This is an impossibly thin thread, and threads this thin don't need to be cut to break. They just need to fall a fraction below the threshold of being heard. So, we face 3 different clocks, all of them ticking at the same time, and all of them counting down to 0. One is the clock of slowly diminishing power. Another is the clock of unrecoverable memories and abilities. The third is the clock of depleting fuel and the loss of the ability to aim. We don't know which of them will reach 0 first. Bildiğimiz tek şey, içlerinden biri durduğunda, aramızdaki sohbetin sonsuza dek biteceği. This will be the moment the story ends for us. But, does this mean the story of the craft is over? This is where most people are mistaken, because losing the craft and the craft stopping are 2 completely different events separated by an unimaginable amount of time. So when this silence begins, what exactly happens to this machine speeding through that vast emptiness? How does it continue to move? Because, in that moment of silence, the craft's motion doesn't stop. Only our ability to observe it stops. This is nothing more than Isaac Newton's oldest and simplest law. Playing out on the grandest stage imaginable, an object in motion stays in motion unless acted upon by a force. On Earth, everything stops because there is always a counterforce: friction, air, the ground. But between the stars, there is no road to create friction and no meaningful air to provide resistance. That is why Voyager 2 has been gliding with its engines off for decades. The end of communication changes only one thing: ease whether someone at home can watch it. This glide brings us to the 4th and most mind-boggling fear: the overwhelming scale of time and distance. We still know its current position. As of early 2026, it is about 143 astronomical units from Earth. 1 astronomical unit is the distance between the Earth and the Sun, about 93 million miles. This means the craft is more than 13 billion miles away. It's moving away from the Sun at about 15 kilometers per second, which is equivalent to 34,000 miles per hour. But these numbers are misleading, because leaving the solar system has 2 different meanings, and we usually think of the wrong one. In 2018, Voyager 2 crossed a boundary called the heliopause. This is where the sun's wind ends and interstellar gas begins. That's why NASA said the craft entered interstellar space, and that is true. But it does not mean it has escaped the sun's gravity. The sun's gravitational dominance, the Oort Cloud, extends up to 100,000 astronomical units. To understand this immense distance, consider this. It will take Voyager 2 about 300 years just to reach the inner edge of the Oort Cloud, and to pass through it completely, leaving the last icy bodies bound to the sun behind, will take about 30,000 years. 30,000 years. This means that for a period longer than the time we've spent building civilization, the craft will still be trying to exit the sun's backyard. This scale confronts us with the meaninglessness of our personal existence. This is the 4th fear of space. That everything we consider meaningful is less than a blink of an eye on the timescale of the universe. But even this 30,000-year journey is still the predictable part. There is still only one boss, the sun. But what happens when that boss's voice becomes too faint to be heard? That's when we face the 5th and final fear: absolute uncertainty and the tyranny of chance. In about 40,000 years, as Voyager 2 exits the Oort Cloud, its path will pass near another star. Ross 248. This is its first date in the future. But it is not a rendezvous, because the star is also moving. Ross 248 is speeding towards our region of space. This encounter is a mere coincidence, the crossing of paths of two independent travellers, and even the word near is misleading. At their closest approach, the distance between them will be about 1.7 light years. That's a little less than 10 trillion miles. This distance is so vast that it would take Voyager 2 tens of thousands of years to traverse this close distance. So, as the craft passes by that star, it will not enter its planetary system. It will not be captured by its orbit. Ross 248 will remain just one of thousands of dim points of light, only slightly brighter than the rest. This is the last and most brutal lesson space teaches us. There is no destination in the universe. There are only orbits and coincidences. No one aimed the craft there. Its direction is a remnant of where Jupiter and Saturn flung it. As it travels this purely accidental path, it encounters another moving target, also by complete accident. This uncertainty multiplies as the timescale grows, because our predictions depend on the quality of the map we have, and our map is constantly changing. Thanks to instruments like the Gaia Space Telescope, we know the positions and movements of stars much better than before. But every new piece of data changes these long-term predictions. Even the encounter distance with Ross 248 can vary by trillions of miles in different calculations. If even our best-known prediction is this volatile, how can we know what will happen millions of years from now? Worse, there are things that are not on our map. There could be billions of rogue planets too dim for us to see, ejected from star systems and now wandering the galaxy alone in the dark. One of these planets could cross Voyager 2's path and alter its trajectory forever. And we can never predict it. This means our predictions are not just incomplete, they are permanently incomplete. We can describe what the visible galaxy will do, but we can say nothing about the invisible galaxy moving right alongside it. When we put all these concepts together, the true source of fear emerges. The slow death of energy, the permanent erasure of memories, the fragility of connection, the crushing scale of time, and finally, absolute uncertainty. All of this shows that no matter how far you go in space, you don't actually arrive anywhere. You just get further away from everything you know and can control. You're no longer an explorer solving the universe's mysteries. You're a piece of wreckage caught in a current. But, so far, we have assumed it's moving in a straight line. What if this is the biggest misconception? What if Voyager 2 isn't actually moving away from the Sun, but is falling towards something much, much bigger? How does the true shape of this journey change everything we've talked about so far? And right there, the entire story changes. Because of that straight line was a lie, an illusion of scale. Voyager 2's journey is not an escape. It never was. It is the beginning of something much bigger, much slower, and much more terrifying, being swallowed by the galaxy itself. Every fear we've discussed so far pales in the shadow of this single, monstrous truth. Now, you will meet the true horror of space. The first shocking discovery was this. The escape is actually an orbit. This seemed impossible. How could an object moving away from the Sun at a staggering 15 kilometers per second actually be in an orbit? But it's like a leaf in a river. If you watch for a few seconds, you think the leaf is going in a straight line. But if you follow it for miles, you see it turns with the bends of the river. Voyager 2 is that leaf. The Milky Way is that river. Its speed of 15 kilometers per second is enough to escape the Sun's gravity. But it doesn't even come close to the speed needed to escape the combined gravity of the Milky Way's 400 billion stars and its massive dark matter halo. That is why the craft, just like our Sun, has joined a gigantic wheel, revolving around the center of the galaxy. One full rotation of this wheel takes about 225 to 250 million years. When the dinosaurs first appeared on Earth, our Sun was at the exact same point in this orbit, and Voyager 2, if it survives, will make about 40,000 turns in this orbit during its 10 trillion year journey. This is a fact that shatters everything we thought we knew, because it proves the craft isn't going anywhere. It is just spinning on a circle so large we can never see it. But that is not the real terror. The second shock is even worse. This orbit isn't even stable. It shouldn't be. A planet's orbit around a star works like a clock. Each turn is almost identical to the last, because there is a single dominant center of mass. But the Milky Way's mass is not concentrated in a single point. It is a lumpy, ever-changing distribution of spiral arms, gas clouds, and dark matter spread over 100,000 light-years. An orbit within such a structure never repeats itself. This is why, with every turn, Voyager 2 is pushed into a slightly different path by the galaxy's shifting gravity, and this accumulates over billions of years. Astronomers call this process gravitational scattering. Over millions of years, the craft will pass by countless stars. Each pass will exert an immeasurably small random push on it, and these small pushes will add up. It's like trying to predict where a single molecule of milk will go when poured into coffee. You know the physics, but the result is completely chaotic. This is why Voyager 2's orbit becomes completely unpredictable over time. The link between where it starts and where it ends is broken. But this scattering is not violent. The probability of a collision is 1 in 10 to the power of 20 years. That's 100 quintillion years. That's 10 million times longer than our 10 trillion year question. The craft will not hit anything. Its path will just be silently rewritten by being repeatedly brushed from afar over billions of years. And now for the real madness. The third shock. Even the galaxy it orbits is not safe. This is an idea that pushes the limits of the mind. This entire system that Voyager 2 is in is moving towards a larger predator, the Andromeda Galaxy. For years, we were told these two galaxies would definitely collide in about 4 to 5 billion years. But then, a study published in the journal Nature Astronomy in 2025 changed everything. Using the latest data from Gaia and Hubble, researchers found that this certain collision is actually a coin toss. Yes, only a 50% chance, because Greenland, the gravity of other galaxies in the local group, makes this grand dance far more complex than we thought. So, what does this mean? In one scenario, the two galaxies merge, and Voyager 2 finds itself in a new galaxy with a completely different shape and mass distribution. According to models by Harvard and Smithsonian, systems like our Sun could be thrown 3 times farther from the galactic center than they are today during such a merger. There's an even more stunning possibility. A 1 in 8 chance that the system could be completely ejected from the galaxy in the merger chaos. So, Voyager 2 could suddenly find itself in intergalactic space. As if all this unpredictability wasn't enough, now we don't even know what the container it's in will be. These 3 discoveries rewrite the definition of fear. We learned that what we thought was a straight line is a massive orbit. We saw that orbit changes not like a clock but randomly and chaotically. And now we understand that the future of the very galaxy it orbits is a coin toss. With each step, we have moved away from certainty and drifted into absolute unknowing. These discoveries make the craft's route completely uncertain. But what about the craft itself? That metal body, those delicate circuits, that golden record carrying humanity's message. In this mind-bending journey of 10 trillion years, what exactly will happen to the physical object itself? It is at this point that the story turns from the location to the object itself. Because the threats to that pile of metal are not just gravitational, but also physical, and the first physical shock is how patient and abrasive the universe is. The probability of Voyager 2 hitting a star or a planet is almost 0. But that doesn't mean it's safe, because interstellar and intergalactic space is not a perfect vacuum. There is an endless rain of high-energy particles, cosmic rays, that pierce through everything. These particles slowly alter the atomic structure of solids, making them brittle and breaking them down at a molecular level. But that's not all. There is also dust. It's not enough to stop the craft, but over 10 trillion years, as it passes through these dust clouds, every single grain hitting it at orbital velocity will sandblast its surface by an infinitesimally small amount. This is like a single drop of water drilling a hole in a rock. After billions of years, even the most durable metals succumb to this relentless erosion. Therefore, after 10 trillion years, the matter of the craft will still exist, yes. But whether it will be in a single piece, or as a cloud of debris drifting along the same path, is much more uncertain. This is the universe's most insidious fear. It doesn't destroy you, it just slowly takes you apart. But what about that message? The letter humanity sent to the farthest reaches? This is where the second physical shock, and perhaps the most painful one, lies. The silent death of the golden record. That record was specially designed to endure the deep future, a gold-plated copper disk. Researchers estimate it could exist as a physical disk for billions of years, maybe even longer. This might be one of the longest-lasting artifacts humanity has ever made. But there is a huge difference between existing as an object and existing as a readable message. All the information on the record lives in microscopic grooves and markings etched into its surface, and these microscopic details are the first target of cosmic rays and dust erosion. Long before the disk disintegrates, the fine encoding that makes it a message will likely be wiped away. Therefore, we must forget the sentimental endings. We cannot promise that the golden record will still be playable after 10 trillion years. The most honest prediction is that what will be left is a worn metal disc, its message long since erased by a cosmic sandblaster. The bottle can last much longer than the letter inside. This is the ultimate fear, showing how even our greatest hope turns to dust in the face of time. So, what is left? Its orbit is uncertain, its galaxy is suspect, its physical integrity is questionable, its message is erased. It is at this point, beyond all this physical destruction, that we face the real philosophical shock. The division of Voyager 2 into two different legacies. This is the final act that reveals the true meaning of the journey. The first legacy is the physical object itself, an aimless, just unconscious piece of old metal, carrying no meaning, just obeying a law of motion. Its journey is not a story of arrival. There is no star it is going to, no one to find it, no coordinate where the journey ends. It just goes on. This is pure, blind, physical persistence. But there is a second legacy, and this is the one that truly matters, because it was the only thing that ever had meaning. It is not the object itself, but the decision to send that object. After 10 trillion years, no one will remember that a species on a small planet, knowing how short its existence was and how low the probability of its message being found was, still built something durable and flung it outwards. We didn't do it because it was useful. We didn't do it because it would come back. We did it as an act of reaching out, a refusal to remain completely silent. This decision is not carried in the grooves of the record that will erode. It is not carried in the structure of the craft that will decay. It is not carried anywhere in the distant future. It survives only in the fact that it once happened. The spacecraft is the artifact of a gesture, and the gesture was always the point. We didn't send it because we expected an answer. We sent it because sending it was a way of saying that we were here, and that we wanted to be part of something bigger than the small slice of time we were given. This is the ultimate truth beyond all fears. Even if we lose everything, the initial act of sending itself is an indelible mark left on the universe. So, how is this technically possible? How did a machine made by human hands manage to escape not just the gravity of the sun, but even the gravity of our own knowledge? What were the exact mechanisms behind this incredible engineering? So, what exactly is the engineering behind this? What are the technical secrets that made this incredible journey possible, that allowed it to survive for so long? Let's slow down from the fast and shocking discoveries and descend into the heart of this machine. Because the story of Voyager 2 is also a story of human ingenuity's struggle against the coldest, darkest, and most unforgiving environments. Three fundamental technical mechanisms form the backbone of this struggle. Now, we will take a closer look at how these mechanisms work. The first and most fundamental mechanism is the craft's lifeblood. G, the radioisotope thermoelectric generators, or RTGs for short. This is the heart of the craft, and this heart does not work like the batteries we know. You can think of it like a stove. Inside, there is plutonium that is slowly decaying. This decay emits a steady stream of heat. What the RTG does is convert this heat directly into electricity. It does this thanks to special materials called thermocouples. When one side of the material is hot and the other is cold, they create a voltage difference, which means an electric current. The greatest genius of this system is that it has no moving parts. There are no gears to wear out, no pistons to break. There is only the predictable and reliable decay of atoms. This makes it incredibly durable. When Voyager 2 was launched, its 3 RTGs together produced about 470 watts of electrical power. The plutonium itself loses half of its heat-generating capacity every 87.5 years. But the real problem is that the thermocouples that convert heat to electricity also lose efficiency over time. When these two effects are combined, the craft permanently loses about 4 watts of usable power every year. This is why for decades, the mission has become an art of subtraction. The engineers have had to constantly sacrifice things to manage this declining budget. First, non-critical heaters, then systems that were no longer needed, and finally, in October 2024, the scientific instruments themselves, like the Plasma Science Instrument, the very reason for the craft's existence. This mechanism perfectly explains why Voyager has survived for so long, but also why it is condemned to a slow and inevitable death. The second critical mechanism is the craft's nervous system. Attitude control and pointing. Without this, power is useless. Because, to talk to Earth, the craft must lock its antenna onto our planet with incredible precision. This is like keeping a flashlight in a dark ocean steady on a match flame tens of thousands of kilometers away. This delicate task is performed by 16 small thruster engines. These engines are fed by a single fuel called hydrazine. As the craft travels along its orbit, it occasionally fires a short puff from these thrusters to correct for small wobbles. This keeps its antenna constantly pointed towards Earth. At launch, it carried about 100 kilograms of hydrazine. This amount, according to the mission's own calculations, was enough to keep the craft oriented until roughly the 2030s. Like the power from the RTGs, this fuel only decreases. When it runs out, the thrusters will fall silent forever. But there is a much more fragile point here. This fuel must not freeze. Hydrazine reaches the thrusters from the tank through thin fuel lines. The cold in deep space where Voyager glides is so intense that these lines could freeze if they are not heated. If they freeze and crack, it doesn't matter how much fuel is left in the tank or how much power is left in the generators. The craft would instantly and permanently lose its ability to aim at Earth. This is why the heater shutdown bargain that engineers constantly make is so risky. Every heater that is turned off is a small gamble that a critical line will not freeze. This system shows that Voyager is not just fighting an energy crisis, but also a constant threat of freezing. The third and most miraculous mechanism is the communication system that brings us the results of all this effort. The Deep Space Network Gissersons, or DSN. This is humanity's ear to the universe. Because Voyager 2 is travelling on a steep trajectory below the plane of the planets, there is only one place that can reliably communicate with it. A massive radio antenna outside Canberra, Australia. This antenna is 70 meters wide. This steel dish, wider than a football field, was built to catch a whisper from the edge of the solar system. Even the word whisper doesn't quite do it justice. Think about what the signal becomes by the time it reaches Earth. It leaves the craft from a transmitter with less power than the small light bulb inside a refrigerator. This weak radio energy travels through more than 13 billion miles of empty space. Over this enormous distance, the signal spreads out, thins, and weakens, as required by the cruel mathematics of space. What finally reaches our planet is almost not a signal, but the ghost of a signal. The fact that we can even catch it is an engineering marvel in itself. That single dish in Canberra must be large and sensitive enough to filter this ghost from the endless noise of the cosmos. As the Earth turns, that dish must track the craft across the sky with flawless precision. Everything depends on this single, fragile link. A single antenna on the underside of a planet, trying to collect a nearly non-existent signal from the darkness. That is why as the craft's power wanes, its radio also weakens. At some point, it will start sending a signal so weak that even the best dish won't be able to catch it. And on that day, without even a goodbye, there will just be silence. These three systems, the slowly dying heart of the RTG, the delicate hydrazine-powered nervous system, and the distant ear of the DSN, work together to make this epic journey possible. Each has its own limits, its own countdown clock. But the era when these systems were designed, the 1970s, was far from today's technological capabilities. So, how did the engineers of that era design a machine so long-lasting and durable? What made them so forward-thinking? And what exactly was the design philosophy behind these systems that are still working today? That is why the design philosophy of that era is still admired today. What made them so forward-thinking was not complex systems, but quite the opposite. Simplicity and redundancy. The simpler a system is, the fewer parts it has to break. Voyager's brain is as primitive as a calculator compared to today's smartphones. But this is not a weakness, it is a strength, because that simplicity makes it more resilient to a constant threat like cosmic radiation. Now, let's look at the other mechanisms underlying this design philosophy. The invisible armor and clever strategies that have kept the craft alive. The first of these strategies can be called a slow and disciplined retreat. This is not just a process managed by engineers from Earth, but a philosophy encoded into the craft's own design. It's like a mountaineer who, after reaching the summit, slowly and safely returns to base camp, using their energy carefully. The summit, the planetary encounters, is long past. Now, the goal is survival. The most concrete example of this philosophy is the order in which the scientific instruments are turned off. This order is not random. The instruments that consume the most power or are no longer critical in interstellar space are sacrificed first. For example, the cameras that took pictures of the planets were turned off shortly after the Neptune flyby because there were no more planets to look at. Their power and memory capacity were transferred to more important instruments measuring the interstellar wind. This is a ruthless but logical prioritization. Engineers describe this process as turning off the spacecraft's senses one by one. The shutdown of the low-energy charged particle instrument in March 2025 was part of this strategy. And next up is the cosmic ray subsystem. Each shutdown decision is a small deliberate amputation performed from 13 billion miles away. The goal is to keep the craft's vital organs, its communication and attitude control systems, operational until the last possible moment. This mechanism shows that Voyager's durability is not just hardware-based, but also based on a smart energy management strategy. The second and lesser-known mechanism is the craft's kinship. Voyager 2 is not alone, it has a twin, Voyager 1. And these twins also serve as experimental subjects. The two craft are travelling in completely different directions out of the solar system. Voyager 1 went up and north, while Voyager 2 dived down and south. This gave them the opportunity to sample two different interstellar environments simultaneously. But, more importantly, it gave engineers a basis for comparison. When an unexpected problem arises on one craft, data from the other can be used to understand the source of the problem. When a system on one begins to fail, preventive measures can be taken for the same system on the other. It's like two sister ships crossing the ocean. A storm on one's route is a warning to the other. This kinship is an invisible insurance policy that has extended the mission's life. But this family has older members too. Pioneer 10 and 11. Launched in the early 1970s, these pioneers have long since fallen silent. The last contact with Pioneer 10 was in 2003. They are no longer spacecraft, they are artifacts, and they provide a living preview of what will happen to the Voyagers. Their silence helps us understand the Voyager's fate. Their trajectories are data points for modelling the Voyager's long-term orbits. This fleet of 5 vehicles, Pioneer 10, 11, Voyager 1, 2, and the more recent New Horizons, are the only objects humanity has sent on an escape route from the solar system. Each one learns from the one before it, and leaves a lesson for the one after. This collective accumulation of knowledge has made possible much more than a single craft could have achieved. The third and final mechanism is perhaps the most philosophical, but also the most practical aspect of this entire journey. The power of aimlessness. Voyager had no goal of going to a specific star or destination. Its route was the result of the gravitational slingshot effects of the planets. It's like a bottle released into a river. You don't try to send the bottle to a specific harbour, you just release it to the current. This aimlessness made the craft incredibly efficient, because making constant trajectory corrections to reach a specific target would have required a huge amount of fuel. Instead, Voyager accelerated almost for free by stealing the momentum of the planets. This is the gravitational slingshot effect. As it passed by Jupiter, Saturn, Uranus, and Neptune, it took a small fraction of their orbital energy and added it to its own speed. This is what propelled it to escape velocity from the solar system. Therefore, its passage by Ross 248 in 40,000 years is not the result of a plan, but a coincidence of this planetary billiards. The fact that its twin, Voyager 1, is approaching another star named Gliese 445 in a completely different direction proves this. This mechanism shows that the most efficient journey in the universe is to surrender to the universe's own flow, to use natural forces to your advantage instead of trying to control them. This philosophy allowed Voyager to save its fuel solely for precise attitude control, thus extending its life by decades. These mechanisms, the disciplined retreat, the learning from sibling craft, and the power of aimlessness, transformed Voyager from a mere hunk of metal into a masterpiece of survival in deep space. This is not just a story about hardware, it is a story of strategy, foresight, and dancing with the rules of the universe instead of fighting against them. But all this technical genius, all this clever planning, brings us to the brink of the biggest question yet. This craft is one of humanity's greatest achievements. But how long can this achievement stand against the largest and most destructive events in the universe? It is time to move away from personal stories and technical details and enter the most violent arenas of cosmic time. Billions of years from now, when galaxies collide, stars die, and the universe itself grows old, what milestones will this small machine's epic journey reach? And now, we come to the true climax. Because, until now, we have always talked about the passive journey of an object, but this story also has an active, unpredictable, and violent side. This is not a story of how durable the craft is, but of how creatively destructive the universe can be. We are leaving the technical details and calm philosophy behind. Now, we will witness the most epic, most mind-boggling, and most terrifying moments Voyager 2 could encounter during its 10 trillion year journey. This is a tale not of a machine, but of the darkest and most glorious scenes of the cosmos itself. Fasten your seatbelts, because the tempo is now going to maximum. The first epic moment. Galactic shockwaves. This was something that shouldn't happen, because guess we thought interstellar space was empty. But it is not. Our galaxy is a living, as breathing entity, and sometimes that breath turns into a violent scream. Supernova explosions, the collision of two neutron stars. These events create massive shockwaves in the fabric of space-time. They are the cosmic version of a tsunami in the ocean, and Voyager 2 cannot escape them on its orbit. A supernova releases more energy in seconds than the Sun will in its entire lifetime. The wave of particles emanating from this explosion travels at nearly the speed of light. For an unprotected craft like Voyager, this is like a butterfly caught in a sandstorm. Its surface is instantly eroded. Its delicate electronic circuits could be fried by the bombardment of high-energy particles. But that's not the worst part. The worst part is the gravitational effect. The shockwave doesn't just carry particles, it is also a wave of mass. As it passes by the craft, it can knock it off its orbit. It can push it onto a more chaotic, more dangerous path. Every few million years, it is statistically inevitable that Voyager 2 will pass through such a wave. This could be a reset moment for it. All that slow, predictable orbit is wiped out in an instant, and the craft finds itself in a completely new and unknown destiny. This is the universe's way of telling it. The rules have changed, and this is a moment that no plan made by humanity could ever foresee. But there is something even bigger than that. The second epic moment, the birth of a star. This is a probability beyond impossible. But 10 trillion years gives time for the impossible. As Voyager 2 glides on its galactic orbit, it will pass through giant molecular clouds. These clouds are the nurseries of new stars. Usually, these passages are slow and harmless. But what if the craft is in exactly the right place? At the critical moment when a cloud begins to collapse in on itself. This would be a first in history. A man-made object would witness the birth of a star. As gravity pulls gas and dust towards the center, Voyager would be pulled along with them. The density around it would increase more than it has seen in millions of years. The temperature would skyrocket from absolute zero to thousands of degrees. The first photons, the first light, emitted from the center of the newborn protostar, would strike that metal body that has been in darkness for 50 years. This would be both a glorious and a fatal moment. The intense radiation would instantly destroy the craft's remaining electronics. The increasing gas friction would slow it down, disrupting its orbit and causing it to spiral inward. Eventually, it would either be swallowed by the newborn star itself or be caught up in the planetary disk forming around the star, becoming part of a new world that will form millions of years later. This would be the end of the craft. But it would also be a rebirth. A part of humanity would become a building block of a new solar system. This is the immortality not of a message, but of matter itself. And now, the most mind-blowing scenario, the third epic moment, exile from the galaxy. This is the ultimate loneliness. We know that the collision of the Milky Way and Andromeda is a coin toss. But what if they do collide? It's like two oceans merging. Billions of stars are thrown about in the chaotic dance of gravity. During that violent merger, some star systems are flung much farther from the galactic center. Some, and this is the most important for us, gain enough speed to be completely ejected from the galaxy, condemned to an eternal exile. According to models from the Harvard-Smithsonian Center for Astrophysics, the probability of a system like our Sun suffering this fate is about 1 in 8. If Voyager 2 is still in orbit around the Sun, or its remnant at that time, it will go on this journey with it. Just imagine. In an instant, it is torn from the family of 400 billion stars it was a part of, and it is thrown into intergalactic space. This is not like being swept from an island into the ocean. This is being thrown out of the ocean itself. Even the light of the faint red dwarfs around it disappears. What remains is only absolute, crushing darkness. It floats alone in the emptiest, coldest place in the universe, millions of light years from the nearest galaxy. This is the deepest loneliness that can befall a machine. It is no longer even part of a galaxy. It is now a ghost of the universe itself. 2, and the more recent New Horizons, are the only objects humanity has sent on an escape route from the solar system. Each one learns from the one before it, and leaves a lesson for the one after. This collective accumulation of knowledge has made possible much more than a single craft could have achieved. The third and final mechanism is perhaps the most philosophical, but also the most practical aspect of this entire journey. The power of aimlessness. Voyager had no goal of going to a specific star or destination. Its route was the result of the gravitational slingshot effects of the planets. It's like a bottle released into a river. You don't try to send the bottle to a specific harbour, you just release it to the current. This aimlessness made the craft incredibly efficient, because making constant trajectory corrections to reach a specific target would have required a huge amount of fuel. Instead, Voyager accelerated almost for free by stealing the momentum of the planets. This is the gravitational slingshot effect. As it passed by Jupiter, Saturn, Uranus, and Neptune, it took a small fraction of their orbital energy and added it to its own speed. This is what propelled it to escape velocity from the solar system. Therefore, its passage by Ross 248 in 40,000 years is not the result of a plan, but a coincidence of this planetary billiards. The fact that its twin, Voyager 1, is approaching another star named Gliese 445 in a completely different direction proves this. This mechanism shows that the most efficient journey in the universe is to surrender to the universe's own flow, to use natural forces to your advantage instead of trying to control them. This philosophy allowed Voyager to save its fuel solely for precise attitude control, thus extending its life by decades. These mechanisms, the disciplined retreat, the learning from sibling craft, and the power of aimlessness, transformed Voyager from a mere hunk of metal into a masterpiece of survival in deep space. This is not just a story about hardware. It is a story of strategy, foresight, and dancing with the rules of the universe instead of fighting against them. But all this technical genius, all this clever planning, brings us to the brink of the biggest question yet. This craft is one of humanity's greatest achievements, but how long can this achievement stand against the largest and most destructive events in the universe? It is time to move away from personal stories and technical details and enter the most violent arenas of cosmic time. Billions of years from now, when galaxies collide, stars die, and the universe itself grows old, what milestones will this small machine's epic journey reach? And now, we come to the true climax, because, until now, we have always talked about the passive journey of an object, but this story also has an active, unpredictable, and violent side. This is not a story of how durable the craft is, but of how creatively destructive the universe can be. We are leaving the technical details and calm philosophy behind. Now, we will witness the most epic, most mind-boggling, and most terrifying moments Voyager 2 could encounter during its 10 trillion year journey. This is a tale not of a machine, but of the darkest and most glorious scenes of the cosmos itself. Fasten your seatbelts, because the tempo is now going to maximum. The first epic moment, galactic shockwaves. This was something that shouldn't happen, because guess we thought interstellar space was empty. But it is not. Our galaxy is a living, breathing entity, and sometimes that breath turns into a violent scream. Supernova explosions, the collision of two neutron stars. These events create massive shockwaves in the fabric of space-time. They are the cosmic version of a tsunami in the ocean, and Voyager 2 cannot escape them on its orbit. A supernova releases more energy in seconds than the Sun will in its entire lifetime. The wave of particles emanating from this explosion travels at nearly the speed of light. For an unprotected craft like Voyager, this is like a butterfly caught in a sandstorm. Its surface is instantly eroded. Its delicate electronic circuits could be fried by the bombardment of high-energy particles. But that's not the worst part. The worst part is the gravitational effect. The shockwave doesn't just carry particles, it is also a wave of mass. As it passes by the craft, it can knock it off its orbit. It can push it onto a more chaotic, more dangerous path. Every few million years, it is statistically inevitable that Voyager 2 will pass through such a wave. This could be a reset moment for it. All that slow, predictable orbit is wiped out in an instant, and the craft finds itself in a completely new and unknown destiny. This is the universe's way of telling it. The rules have changed, and this is a moment that no plan made by humanity could ever foresee. But there is something even bigger than that. The second epic moment, the birth of a star. This is a probability beyond impossible. But 10 trillion years gives time for the impossible. As Voyager 2 glides on its galactic orbit, it will pass through giant molecular clouds. These clouds are the nurseries of new stars. Usually, these passages are slow and harmless. But what if the craft is in exactly the right place? At the critical moment when a cloud begins to collapse in on itself. This would be a first in history. A man-made object would witness the birth of a star. As gravity pulls gas and dust towards the center, Voyager would be pulled along with them. The density around it would increase more than it has seen in millions of years. The temperature would skyrocket from absolute zero to thousands of degrees. The first photons, the first light, emitted from the center of the newborn protostar, would strike that metal body that has been in darkness for 50 years. This would be both a glorious and a fatal moment. The intense radiation would instantly destroy the craft's remaining electronics. The increasing gas friction would slow it down, disrupting its orbit and causing it to spiral inward. Eventually, it would either be swallowed by the newborn star itself or be caught up in the planetary disk forming around the star, becoming part of a new world that will form millions of years later. This would be the end of the craft. But it would also be a rebirth. A part of humanity would become a building block of a new solar system. This is the immortality not of a message, but of matter itself. And now, the most mind-blowing scenario, The third epic moment, exile from the galaxy. This is the ultimate loneliness. We know that the collision of the Milky Way and Andromeda is a coin toss. But what if they do collide? It's like two oceans merging. Billions of stars are thrown about in the chaotic dance of gravity. During that violent merger, some star systems are flung much farther from the galactic center. Some, and this is the most important for us, gain enough speed to be completely ejected from the galaxy, condemned to an eternal exile. According to models from the Harvard-Smithsonian Center for Astrophysics, the probability of a system like our Sun suffering this fate is about 1 in 8. If Voyager 2 is still in orbit around the Sun, or its remnant at that time, it will go on this journey with it. Just imagine. In an instant, it is torn from the family of 400 billion stars it was a part of, and it is thrown into intergalactic space. This is not like being swept from an island into the ocean. This is being thrown out of the ocean itself. Even the light of the faint red dwarfs around it disappears. What remains is only absolute, crushing darkness. It floats alone in the emptiest, coldest place in the universe, millions of light years from the nearest galaxy. This is the deepest loneliness that can befall a machine. It is no longer even part of a galaxy. It is now a ghost of the universe itself. But what if it survives? What if it survives all of this? Here is the fourth and most philosophical epic moment. The last witness, 10 trillion years later. The universe has aged. Our sun has long since burned out, cooling as a white dwarf. The merger with Andromeda has happened, or not. It's now an old memory. All the bright, massive stars in the galaxy have died. Only the long-lived faint red dwarfs remain. The universe has entered a twilight era, and Voyager 2, if it is still in one piece and still somewhere in that galaxy, becomes the most unique object in history. It is one of the last witnesses to have seen the age of bright stars. It is one of the rare objects that remembers, physically, what a star like the Sun looked like. The metals on it were forged on Earth, on the third planet of the solar system, by the explosions of massive stars billions of years earlier. So, its atomic structure is an echo of a universe that no longer exists. It is not just a spacecraft, it is a time capsule, an archaeological artifact. For any future civilization, if any exist, finding it would be much more than finding a dinosaur fossil. It would be finding the key to a lost age of the universe. In this scenario, Voyager 2 becomes a memory not of humanity, but of the universe itself, and this gives it an importance we can't even imagine. These 4 moments, a galactic tsunami, the birth of a star, exile from the galaxy, and being the last witness, show that Voyager 2's journey is not just a passive drift. It is an active, violent, and transformative epic. So, what do all these possibilities, all this violence and grandeur, tell us about the nature of the universe and our place in it? What conclusion does the sum of these epic moments draw about the ultimate meaning of this journey? Therefore, the ultimate meaning of this journey is much more than a passive survival story. It is a series of violent and transformative encounters with the most fundamental forces of the universe. Each epic moment changes not just the craft's location, but its identity. It is no longer the simple machine launched in 1977. It is an artifact washed in galactic tsunamis, forged in the fire of a star's birth, has tasted the absolute loneliness of being exiled from a galaxy, and carries the weight of being the last witness of an era. This is the story of an object becoming as complex and unpredictable as the universe itself, and there are even deeper, stranger chapters in this story. The 5th epic moment. An encounter with a rogue planet. This is not like passing by Ross 248. This is a completely different level. Rogue planets are orphan worlds, ejected from star systems, drifting alone in the dark. We cannot see them, we cannot catalogue them. But they are there, billions of them, perhaps, and in 10 trillion years, it is almost certain that Voyager 2's path will cross with one of them. This doesn't have to be a collision. It could be something much more interesting, gravitational capture. If Voyager passes by a sufficiently large rogue planet at the right speed and angle, it could be captured by that planet's weak gravity. This would be the strangest adoption in history. After drifting alone among the stars for billions of years, Voyager 2 would suddenly become the first and only artificial moon of a world. Just imagine. It escaped the sun, it roamed the galaxy, and in the end it entered the orbit of a dark Quayan, frozen world it had never known. It is no longer a free traveller, it is now a prisoner. But it would also have found a new home. Together with that rogue planet, it would enter a new path within the galaxy. Perhaps that planet would be captured by another star, and Voyager would find itself part of a completely new solar system. Or perhaps they would drift forever together with that dark world, as the loneliest couple in the universe. This scenario shows how unpredictable Voyager's fate is. It doesn't need big, violent events like the birth of a star or the collision of a galaxy. Sometimes, the biggest changes come from an invisible neighbour, approaching silently in the dark. But what if something even stranger happens? The sixth epic moment. The paradox of knowledge. This is not a physical, but a philosophical climax. After 10 trillion years, Voyager 2 might be the only remaining physical evidence of our civilization. Even if the message on the golden record has worn away and become illegible, the craft itself, its very existence, is undeniable proof that it was made by intelligent life. The straight lines on it, the 90-degree angles, the exotic metal alloys, these do not occur naturally. So, for any future intelligent being, finding it would be proof that they were not alone in the universe. But here is where the paradox begins. The civilization that finds it will likely be billions of years older and wiser than us. Our technology will seem as primitive to them as a stone axe. But that primitive object will answer one of their most fundamental philosophical questions. Was there other intelligent life in the universe? The answer is the piece of metal they hold in their hands. Yes. But this answer raises new and more disturbing questions. So what happened to them? Why is only this silent wreckage left? While its existence gives hope, its silence becomes a warning. It is a tombstone of the universe, a stone that says, "We were here," but cannot tell the rest of the story. This is knowledge in its most cruel form. It gives an answer, but that answer only creates more questions, and for those who find Voyager, it becomes an eternal reminder of how dangerous the universe can be and how fragile civilizations are. And now, beyond all these possibilities, the ultimate moment, the seventh epic moment, the final dance of matter. This happens far beyond 10 trillion years, in the final moments of the universe itself. But Voyager's fate is shaped on the path leading to that moment. After the age of stars ends, the universe enters the degenerate era. All that remains are white dwarfs, neutron stars, and black holes. Galaxies slowly evaporate due to billions of years of gravitational scattering. Stars and planets are torn from their galactic homes one by one and cast into the darkness. Voyager 2, if it is not bound to a star or planet, gets its share of this evaporation. But the real event is proton decay. According to some theories, even the most stable particles in the universe, protons, cannot exist forever. After an incredibly long time, perhaps 10 to the power of 36 years, they begin to decay. This is the dissolution of matter itself. The aluminum, titanium, and gold atoms that make up Voyager 2 will turn into more fundamental particles and radiation one by one. This is not an explosion. This is the slowest, most silent annihilation imaginable. For billions of trillions of years, that metal body will evaporate atom by atom until nothing is left. This is the ultimate end of the craft. Not a collision, not an erosion, just the fundamental rules of the universe finally erasing it. This is the most absolute end, because as Sus stored, not even wreckage remains, only a faint trace of radiation, a memory of something that was once there. This shows that even the most durable object humanity has ever sent into the universe is nothing in the face of infinite time. These epic moments, being adopted by a rogue planet, becoming a paradoxical tombstone of knowledge, and the ultimate dissolution of matter itself, reveal the full picture of the journey. This is not just the story of a machine, It is the story of matter, knowledge, and time itself. It is proof of how vast, how old, and how ruthless the universe can be. But in the midst of all this violence, chaos, and ultimate annihilation, what was the meaning of that first gesture, that first act of sending? Now it is time to stop and think. What is the true meaning of this cosmic epic, of this little bottle in the ocean? For us living here today. But now it is time to stop and think. Let's pause these epic moments that have been moving at maximum speed for a moment and ask ourselves the most basic question. All this chaos, this immensity, these mind-boggling timescales, what do they mean for us, for the short-lived beings on this small planet? The journey of Voyager 2 is not just the story of a metal object. It is a mirror we use to understand our place in the universe. And when we look into that mirror, we're confronted with a series of deep and unsettling contrasts. Now is the time to dive into those contrasts and understand the philosophical truths that this cosmic epic whispers to us. The tempo's slowing down because the answers to these questions cannot be rushed. The first and most fundamental contrast we face is about scale. Overwhelming vastness and microscopic meaning. On one hand, there is a timeline of 10 trillion years. This is 720 times longer than the current age of the universe. On the other hand, there is the average 80-year human lifespan, belonging to the hands that designed and built this machine. On one hand, there is a void where even the nearest star encounter happens from a distance of 1.7 light-years, about 10 trillion miles. On the other hand, there is a scientist, perhaps sitting in an office of just a few square meters, who calculated that encounter, who wrote those numbers on a piece of paper. How can these two scales coexist? This paradox reveals the most tragic truth of our existence, how physically insignificant we are. The 13 billion miles that Voyager 2 has traveled in 50 years is less than 1/400th of that close, distance to Ross 248. This means that we can never, ever physically reach those stars. We are trapped on this planet, in this solar system. Our bodies are too slow, too fragile, and too short-lived to cross this cosmic ocean. This is a moment of sadness. The sadness of looking at a vast landscape and knowing that you can never reach that horizon. But it is at this very point that the incredible transformation occurs. Because, even though we cannot physically go there, our minds are already there. It was not our muscle power that sent Voyager 2 there, it was our minds. It was our minds that calculated that 10 trillion mile distance, that foresaw that 40,000-year journey, that designed the atomic structure of that machine. Our bodies may be in a cage, but our consciousness can travel from one end of the universe to the other. And this is the most beautiful truth of being human. We are a part of the universe that can understand the universe itself. Therefore, you too are not just a speck of dust in this vast cosmos. You are a universe contained within that speck of dust. While you struggle with the limits of your own life on one hand, on the other, you can dream of a 10 trillion year journey with your mind. And this makes you one of the most powerful beings in the universe. This brings us to the second contrast, permanence and transience. On one hand, we have one of the most durable objects ever made by humanity, potentially existing for 10 trillion years. Voyager 2 can continue to exist even after the Sun has died, after the Milky Way and Andromeda have merged, and after the age of stars has ended. This is an almost godlike permanence. On the other hand, there is the incredible fragility of the civilization that sent that object. Our entire recorded history is only a few thousand years, and this is nothing next to the 30,000 years it will take for Voyager to cross the Oort Cloud. On one hand, there is eternity, on the other, there is a moment. How can these two truths coexist? The tragic part of this situation is seeing how much we will be left behind by our own creation. When Voyager 2 falls silent, when the last person who remembers it dies, when our cities turn to dust and our planet becomes unrecognizable, it will still be there. While all evidence of our existence has been erased, it will continue to bear witness on our behalf. It is more permanent than us. This is the story of the Creator being forgotten by its own creation, and this carries a deep melancholy. But, at the same time, there is an incredibly beautiful side to this situation, because this permanence means that a part of us has reached eternity. Every atom of that metal was forged on Earth. Every line of that design was drawn in a human mind. The gesture itself, the act of sending, was the result of our collective will. Therefore, as long as Voyager exists, humanity also continues to exist in some way. It is our farthest-reaching legacy, an indelible signature that our momentary existence has etched into the fabric of eternity. You two live in the middle of this paradox. Your life is also a moment, short and transient. But, within this short moment, you two have the potential to create something permanent, to leave a mark, to be part of a story bigger than yourself, just like the engineers who built Voyager. Most of them are not alive today. But their work will be gliding through the universe even after 10 trillion years, and this brings us to the third and perhaps most personal contrast. Absolute loneliness and deep connection. The journey of Voyager 2 is a definition of the deepest loneliness imaginable. It is billions of miles away from even its closest relative, just G, Voyager 1, Russ, moving in opposite directions. Even its encounter with the nearest star will leave a gap of trillions of miles between them. And if it is ejected from the galaxy, it will literally become the loneliest object in the universe. This is not like a snowflake drifting alone in an ocean. This is that snowflake being thrown out of all oceans and all continents into the void. This absolute isolation reflects one of the most fundamental fears of existence, the fear of being alone. This is a tragic picture, humanity's greatest ambassador becoming its greatest prisoner. But there is another side to the coin, and that side shows the power of connection. It was not the decision of a single person that sent Voyager 2 there. It was the product of decades of collective effort by thousands of scientists, engineers, technicians, and dreamers. It is proof of what people from different countries, different cultures, and different generations can achieve when they come together for a common purpose. Moreover, that craft is still connected to that single antenna on Earth, that 70-meter dish in Australia. This is one of the thinnest, most fragile, but also most stubborn bonds in the universe. That bond is a symbol of how far we can collectively reach. It may be a lonely object, but it was never the product of a lonely idea. It is a monument to the best of us, to our capacity to work together and reach for the unknown. You two experience this contrast in your life every day. Sometimes you may feel in absolute loneliness, misunderstood, isolated. But remember that you too, just like Voyager, are connected to others by invisible threads, to your family, your friends, your community, and even to the people who recorded the sounds on that golden record, who launched that craft. You are a part of that great and complex network called humanity, and that bond is stronger than even the deepest loneliness of the universe. These contrasts, vastness and meaning, permanence and transience, loneliness and connection, do not just tell us the story of Voyager, they tell us our story. But there are more layers to be discovered in this philosophical journey. How much deeper can we look into this mirror, and in those depths, on that fine line between hope and fear, what more can we learn about ourselves? And therefore, when we look deeper into this mirror, we discover an even more fundamental truth about ourselves. This truth relates to the delicate dance between knowledge and ignorance. Because Voyager's journey is a painful lesson that shows not only how much we know, but also how little we know and how fragile knowledge itself is. This is perhaps the most uncomfortable, yet most enlightening stop on the entire philosophical journey. This is the moment of confronting the infinite chasm between what we know and what we can never know. This brings us to a fourth contrast, certainty and uncertainty. On one hand, we know the current position and velocity of Voyager 2 with incredible certainty. We have tracked it to kilometer-level precision throughout this conversation. We know its speed of 15 kilometers per second, its distance of 143 astronomical units, even the 48-degree inclination of its orbit. This is a triumph of the human mind and its ability to measure. This is one of the most solid, most reliable truths that science offers us. On the other hand, there is an absolute uncertainty about where it will be in 10 trillion years. There is no map to chart its orbit. There is no list of the stars it will encounter. Even the shape of the galaxy it will be in is a mystery. On one hand, almost absolute knowledge, on the other, almost absolute ignorance. How can these two opposites be part of the same story? The tragic part of this paradox is seeing how our knowledge erodes over time and eventually disappears completely. In the beginning, everything was under our control. We sent a command, we got a response. But, as distance and time increased, this control slowly slipped from our hands. First, we lost the ability to hear, then the ability to predict, and eventually we will even lose the ability to imagine. This is like watching a library burn down slowly. First a few pages burn, then a shelf, then a room, and finally, only ashes remain. This is our helplessness in the face of the inevitable death of knowledge. But, within this tragedy shines a magnificent beauty. Because this uncertainty also means that the possibilities are infinite. Voyager 2's destiny is not pre-written. It is a story that is being rewritten at every moment. Every star encounter, every galactic shockwave is a new beginning for it. This is proof of how dynamic, how alive, and how full of surprises the universe is. Our search for certainty contradicts the chaotic nature of the universe. And when we accept this uncertainty, we understand the beauty of the universe more deeply. You too live this dance of certainty and uncertainty in your own life every moment. You make plans, you set goals, you try to chart the course of your life. But, at the same time, you know that what tomorrow will bring is completely uncertain. A coincidence, an unexpected encounter, can change everything. And this is as exciting as it is scary, because it means the story is not over yet, just like Voyager's story. Finally, we face perhaps the most important contrast: purpose and aimlessness. On one hand, Voyager 2 is one of the most purposeful objects in human history. It was launched with clear and noble purposes to collect scientific data, to discover new worlds, and to announce humanity's existence to the universe. Every instrument, every circuit on it was carefully designed to serve these purposes. The golden record is the most concrete symbol of this purpose. We are here, and we want to meet you. This is a beginning filled with meaning, intention, and hope. On the other hand, there is its state after 10 trillion years. Its power is depleted, its instruments are silent, its message is erased, its orbit is random. It no longer serves any purpose. It just exists. A meaningless hunk of metal obeying Newton's laws. On one hand, absolute purpose. On the other, absolute aimlessness. This transformation causes us to ask the deepest questions of our existence. The tragic part of this situation is seeing how even our noblest purposes can become meaningless in the face of time and the universe's indifference. We sent a message out there. But the universe does not seem to have an ear to receive that message. We set out with a purpose, but the journey itself slowly erased that purpose. This is a sad proof of how small and ineffective our intentions can be on a cosmic scale. It's as if we threw a letter into the ocean, and that letter is doomed to drift forever, unread by anyone. But, within this aimlessness, perhaps the deepest meaning is hidden, because Voyager's real purpose was not to reach a destination or get an answer. The real purpose was the act of sending itself. That act was something that defined who we are. We are a species that reaches for the unknown, that asks questions without expecting answers, that does not give up trying even when it seems hopeless. Voyager's journey is a physical manifestation of this spirit. Its current aimlessness makes the purity and beauty of that initial purpose shine even brighter. That gesture, that moment of sending Uranus was a whole in itself, and the echo of that moment, even after 10 trillion years, even when the object itself has become meaningless, continues to exist in some way in the fabric of the universe. You too are searching for meaning in your life. You're trying to find a purpose. Sometimes these purposes can be big and clear, and sometimes life can seem aimless and meaningless. But maybe the real point is not to find a destination to arrive at, but the journey itself. Maybe the meaning is hidden in every step you take, in every question you ask, in every moment you reach for the unknown. Just like Voyager, its greatest meaning lies not in arriving somewhere, but in just continuing to go. These philosophical contrasts, certainty and uncertainty, purpose and aimlessness, take us to the heart of the human condition. We are beings who walk on the fine line between what we know and what we don't know, what we can control and what we can't, what is meaningful and what is meaningless. Voyager 2 is the farthest and loneliest representative of our dance on this cosmic tightrope. We now know that its journey is a reflection of our own journey. But there is one more layer to see in this reflection. In such a vast, ancient, and indifferent universe, what does the word hope itself mean? And what can the story of this small, though fragile machine teach us about the nature of hope? And now, these thoughts confront us with an even deeper question. In such a vast, ancient, and indifferent universe, what does the word hope itself mean? The story of Voyager 2 gives us the opportunity to rethink not only the size of the universe, but also the nature of hope. This is the final and most personal layer of our philosophical journey. Because, at this point, we will no longer focus on the universe or the machine, but on how we live with this knowledge and how we look to the future. This is an effort to find that delicate balance between the weight of knowledge and the lightness of action. This brings us to a new contrast: knowledge and inaction. On one hand, we have incredible details about the future of the universe. We can model the potential fate of Voyager 2 after 10 trillion years, the death of stars, the collision of galaxies, and even the decay of protons. This is one of the greatest triumphs of the human mind. Our knowledge transcends the boundaries of time and space. On the other hand, there is our absolute inaction in the face of these massive cosmic events. We know whether Andromeda will collide with the Milky Way, but we can do nothing to stop it. We know that the Sun will one day die, but we cannot prevent this inevitable end. We understand the most fundamental rules of the universe, but we do not have the power to change those rules. On one hand, an almost divine ability to understand, on the other, an absolute physical powerlessness. How can these two truths coexist? The tragic part of this paradox is that our knowledge brings us not power, but a burden. To see the future but not be able to change it is the curse of a prophet. It's like a person who sees a train approaching but is tied to the tracks. You know what will happen, but you wait helplessly. This is a sadness that comes with knowledge, the sadness of realizing that understanding does not mean controlling. But, within this powerlessness, one of the noblest aspects of the human spirit shines. Even though we know a future we cannot change, we still do not give up trying to understand. We seek that knowledge, we build those models, we solve those equations. Why? Because understanding is an action in itself. We may not be able to change the rules of the universe, but by understanding those rules, we establish a deeper relationship with the universe. It ceases to be a strange and frightening place to us. It becomes a system that we understand, that we are a part of. Knowledge may not give the power to control, but it gives the power to accept and to admire. And that, perhaps, is the greatest power. You too encounter truths in your life that you cannot change. You cannot change the past. You cannot bring back some losses. But, by understanding them, you can make peace with them. This is the greatest gift of knowledge. It gives you not control, but peace. This situation directs us to the next contrast: silence and message. On one hand, there is the overwhelming silence of the universe. There are billions of galaxies, billions of stars, but so far, all we have heard is a great void. The golden record of Voyager 2 is a scream thrown into this silence, but no answer has come to that scream. Maybe it never will. This seems to be the most concrete evidence of our cosmic loneliness. We are beings who talk, sing, and wonder. But the universe does not seem to speak our language. On the other hand, there is the fact that silence itself can be a very meaningful message. Maybe the universe is not silent. We are just not listening to the right frequency. Maybe communication does not happen through sound waves or radio signals as we understand them. Maybe the universe speaks through the birth of stars, the dance of galaxies, the whisper of gravitational waves. And we are just beginning to learn this language. The tragic part of this paradox is that there may be conversations, songs and stories all over the universe, but we do not have the biological or technological equipment to hear them. This is like a deaf person surrounded by music. They think they are alone, but they are actually in the middle of a symphony. This is the sadness of the connection we are potentially missing. But there is a hopeful side to this silence, because if this is the language of the universe, the language of matter and energy, then we're also a part of that language. Our existence, our civilization, the Voyager probe we sent, is a sentence the universe writes to itself. We are one of the ways the universe expresses itself. The golden record may not receive an answer, but the existence of that record, the gesture itself, is the most meaningful answer given to the silence of the universe. We too are a voice. We too are a note. You too encounter silence in your own life sometimes. You ask questions, but the answers do not come. But maybe the answer is in the question you ask. Maybe your existence, your curiosity, your search for meaning, is the most beautiful melody you add to the silence of the universe. And this brings us to the final philosophical contrast: end and beginning. On one hand, the journey of Voyager 2 is defined by an inevitable end. Its power will run out, its signal will be cut off, it will be broken into pieces, and eventually, it will be completely destroyed by proton decay. This underlines the fact that everything ends, that every story comes to an end at some point. This is the most fundamental law of mortality. On the other hand, there is the idea of how every end can be a new beginning. If Voyager 2 is caught in the birth of a star, its atoms can become part of a new planet. If it becomes the moon of a rogue planet, it starts a completely new story. Even when it is destroyed by proton decay, its energy and fundamental particles return to the fabric of the universe and perhaps, trillions of years later, become part of a new structure. On one hand, an absolute end, on the other, an infinite transformation. How can these two ideas coexist? The tragic part of this situation is facing the fact that everything we know, recognize, and love will one day be destroyed. People, civilizations, stars, and even matter itself. Nothing is permanent. This is the most universal form of the feeling of loss. But in this inevitable end lies the deepest hope, because if nothing is truly destroyed, but only transformed, then death is not an end, but a transition. Then a farewell is the beginning of a new hello. The story of Voyager 2 is the most epic scale version of this cycle. It began as an idea of humanity, turned into a machine, became an explorer, will be an artifact, and perhaps will eventually return to stardust. This is the most fundamental rhythm of the universe, creation and destruction, and we're also a part of that rhythm. You too face endings in your life. A job ends, a relationship ends, a period closes. But every end creates an opportunity for a new beginning. Anew you can be born from your ashes, because you, just like Voyager, are not just an object. You're a process that is constantly transforming, constantly restarting. This final layer, these deep thoughts, have brought us somewhere. We no longer look at the universe as just a collection of objects, but as a whole of processes. We no longer look at ourselves as just an individual, but as a part of those processes. But is this philosophical journey over? Or are all these thoughts preparing us for an even more fundamental, more personal conclusion? Therefore, at the end of this philosophical journey, all these thoughts are preparing us for an even more fundamental, more personal conclusion. This is no longer about the universe or the machine, but about how we live with this knowledge. This final layer moves beyond hope and fear to settle in the subtle space between acceptance and meaning. Because when Voyager's story ends, all that will be left is what it taught us, and those lessons will echo much closer to us than interstellar distances, right in our own hearts. This brings us to that final contrast between legacy and oblivion. On one hand, the very act of sending Voyager seems to be the most enduring legacy humanity has left to the universe. It is a symbol of our curiosity, our courage, and our desire to reach for the unknown. For any future beings, it will be proof that we once existed. This is a legacy that transcends time. On the other hand, there is the fact that even that legacy is so incomplete and fragile. Voyager cannot tell who we were. It only says that we were. It cannot carry our art, our music, our love, our fears, our wars, our peace. the billions of complex details that make us who we are. Even the golden record is no more than a postcard thrown into the ocean. The tragic part of this paradox is that even the greatest mark we leave behind will be only a faint shadow of our story. Even our greatest achievement will be insufficient to tell who we were. We are like an actor who leaves the stage without being able to tell their own story. Only our costume will remain, but our lines will be lost forever. This is the sadness of ultimate oblivion. But within this incomplete legacy lies an incredible beauty. Because this situation shows that the real legacy is not in that piece of metal, but here, now, among us. The real legacy is the stories we tell each other, the knowledge we pass on to each other, the love we show each other. Voyager may have sent a message to the universe, but the real messages are the ones we send to each other every day. Its journey reminds us how precious the connection between us is, because the universe may not remember us, but we can remember each other, and perhaps this is the most important legacy. You too create your own legacy every day. Every word you say, every action you take, leaves a mark behind, and the most important of these marks are not left in distant galaxies, but in the hearts of the people next to you. So, how do you feel at the end of this journey? On one hand, a sense of being crushed by the vastness of the universe and our insignificance, or on the other hand, a sense of awe and pride for having a consciousness that can comprehend this massive cosmos. Probably both, and that's normal. Because beyond Voyager's story shows how valid both of these feelings are. We're right to feel small, because physically, we are. But we are also right to be proud of ourselves, because mentally, we are as vast as the universe itself. This journey does not give us an answer. It teaches us to ask the right question, and that question is, knowing these two truths, how will we live our short lives? This is the final and greatest challenge Voyager leaves us. Throughout this journey, we have watched a machine advance towards silence. But, in reality, we have made a journey into ourselves. We have seen how knowledge dies, how time is overwhelming, how uncertainty is inevitable. But, we have also understood how the human mind can embrace the universe, how collective effort can create miracles, and how even the deepest loneliness can be overcome by the power of connection. Vastness and meaning, permanence and transience, loneliness and connection, knowledge and inaction, silence and message, end and beginning. All these philosophical contrasts have brought us to a single truth. The universe does not care what we think about it. But what we think about it changes everything. We now know that Voyager 2 is not just a hunk of metal. It is a reflection of our greatest questions, our deepest fears, and our most unshakable hopes. And now we have come to the end of this long, deep and calm journey. It is time to bring all that we have learned together and return to that first question. That simple yet most profound question. 10 trillion years from now, where will Voyager 2 be? And therefore, the most honest answer to the question of where Voyager 2 will be in 10 trillion years is not a coordinate, but an understanding. In this journey, we listened to the slowly dying heart of a machine. We witnessed its erased memories, and we drifted with it through the most epic scenes of the universe. We descended into the deepest layers of philosophy, and there, in the mirror of the universe, we saw our own reflection. We now know that Voyager's story was not about arriving somewhere. It was about just continuing to go. Because the greatest discovery of this journey was not finding a new world in space. The greatest discovery was that even the most absolute silence, the greatest uncertainty, and the most crushing loneliness cannot destroy the human mind's desire to understand and the pure beauty of that first gesture of sending. You too are a part of this universe. In your own life's journey, you face your own uncertainties and your own silences. But remember that your existence, just like Voyager, is a mark left on this cosmos, and the value of this mark is measured not by its arrival at a destination, but by the journey itself. If this long and deep journey has given you a new perspective on your place in the universe, you can press the like button to share these thoughts and subscribe to the channel, because we too, just like Voyager, are trying to add our own voice to this cosmic conversation. And in this conversation, we have learned that even the smallest objects can whisper the greatest truths. But what if the smallest things, the subatomic particles, are writing the rules of this massive universe in a completely different way. In this journey, we watched an object glide through the universe, obeying Newton's laws. But I didn't tell you something. That object itself, at the subatomic level, does not obey these rules at all. There, a particle can be in two places at the same time. The future can affect the past, and the fabric of the universe is much stranger than what we call reality. On our next journey, we will ask whether these mind-boggling rules of the quantum world could also apply to massive objects like Voyager. Are you ready?